Okay, we're doing the purple one. Here we are. We got to find the absolute minimum. So we're going to find the absolute minimum, and we're going to do that by finding our critical values first, because what we have to do is we have to plug in our critical values and the endpoints to see which endpoint or which x value will give us the smallest y value. So first I'm going to take our f prime, and I'm going to set it equal to 0. I take out a greatest common factor, which is going to be 12x. And I take each of those factors and set them equal to 0. For the first factor, I get 0. And for the second factor, I get positive 1. And so 0, 1, well, negative 4, 3, 0, and 1. Those are going to be the x values I have to test. So let's plug all those suckers into F and see what y values you get. And we're looking for the minimum. So we're just looking for the smallest y value. Okay, so we got... this is, you're not supposed to see that. All right, give me a sec. That's what I wanted to tell you. The absolute minimum value is a y value. That's important to note. Okay, so when I plug in 0, I get 1. And that one's pretty easy to plug into because those two terms become 0. I add 1, I get 1. Okay, the next one, if I plug in 1, that one's pretty simple too. We get a negative 4, a positive 6, and the 1. And when I add all those up, see, negative 4 and 6 is positive 2 plus 1. That'll give me a 3. And then I got to plug in negative 4, which is going to be a little bit more work. So if I plug in negative 4, I get negative 64 when I raise negative 4 to the third power. And I'm multiplying that by a negative 4. And then I plug in negative 4 to x squared, and I get a positive, not negative, a positive 16. So let's go like this, put a little positive right there. Okay, and then I had the plus 1. Okay, check that out. Look at this. That's going to be positive, that's going to be positive, that's going to be a positive 1. So we're just going to get a really big positive number, which is clearly greater than 1, right? Yeah, so 1 would be smaller than that. So I don't even care. I don't care what we get for negative 4. So let's skip that guy. So this dude's out. I don't even care. All right, now I plug in the 3. When I plug in the 3, I get positive 27. And I get 6 times 9. And then I have a positive 1. That's going to be a big negative number. Look at that guy. Oh, dang it. I don't want to multiply those. I hate multiplying. Let's see. I get, 4 times 20 is 80, right? Like just a 2. 4 times 20 is 80. What is 4 times 7? 28. So I just have to add those guys together. And then I have 6 times 9, which is 54. And then I have 1. Okay, what do I get when I add those negatives together? This is 55. Those are the positives. And then my negatives, I get negative 108. And when I add those two guys up, I get negative 53. So this is where, this is the critical value. Wait, no, this is the endpoint, huh? So at the endpoint, we have a negative 53. And negative 53 is clearly the minimum, the least y value out of all of them. So because it's asking for the y value right here, the negative 53 is our answer, not the 3. The 3 is where the minimum value is. Negative 53 is the minimum y value or the minimum value. And so just to recap, I didn't have to find the y value for negative 4 to see if it was less than negative 53 because when I did this right here, it was going to be a ginormous positive number that was clearly bigger than 1 or 3. So negative 4 could not have provided us with the minimum y value.